Let's go ahead and take a look at three of these quadratic form problems we talked about in class. The first one is x plus x to the 1/2 power minus 6 is equal to 0. And the first thing that I wanted to do is see if it is in quadratic form. So what we talked about in class, whether it's in quadratic form or not, is we take the smaller exponent, which is 1/2, multiply it by 2, and if that's equal to the exponent of the larger, then it's in quadratic form. So we get that it's equal to 1. And on the x there, right here, we don't see it, but it has an exponent of 1. So we let u equal the smaller exponent expression. So u equals x to the 1/2. Then u squared would be x to the 1/2 squared, which is just x. So to speed that up, u squared is equal to x. So we'll replace the x to the 1/2 and the x with the u and the u squared. So we're going to go ahead and substitute those in. Okay, now this is in quadratic form, so this is something that we can factor pretty simply. The product here is going to be -6 and the sum is +1. So our factors here would be +3 and -2. And then at this point in time, we'll set both our factors equal to 0, solving both of those. So u plus 3 equals 0, we subtracted 3 from both sides. U minus 2 equals 0, we added 2 to both sides. So remember that x to the 1/2 is the same thing as the square root of x. Okay, so that's what's happening here. Okay, so u is x to the 1/2, and x to the 1/2 is the square root of x. So why we're changing it here is because then it reminds us that to undo a square root, we'll go ahead and square. So I mentioned it again there. So we're going to go ahead and square both sides. X is equal to 9 or x is equal to 4. So we need to check our solutions to make sure we don't get any imaginary numbers or stuff that's just simply not true. So we need to check them both in the original, and it's good to use x to the 1/2 as the square root of x instead. So we're going to go ahead and check 9. So 9 plus square root of 9 minus 6 equals 9 plus 3. The square root of 9 is 3 minus 6. So that gives us an answer of 6, and that's not 0. So we have a fancy name. We call this as extraneous, and it's a solution that does not work. Now if we try our other solution, x equals 4, plug it in, 4 plus square root of 4 minus 6 gives us 4 plus 2 minus 6, and that is in fact equals 0. And so that one is a solution. So we only have one answer. We got two answers trying to solve it, but only one of them worked. So our answer here is 4. Okay. Let's go ahead and look at another example. This is the second one we did in class on this subject. So x to the 4th minus 10x squared plus 25 equals 0. The smaller exponent is 2, and so we're going to take that smaller exponent, multiply it by 2, and if it's equal to the larger exponent, then we're probably in quadratic form. And in fact we are. So we'll let u equal the smaller x squared. U squared will be x to the squared, which is x to the 4th. So we have u is equal to x squared, and u squared is x to the 4th. So we're going to replace the x to the 4th with a u squared, and we're going to replace the x squared with a u. And we'll have something much easier to factor. So here the product's 25, and the sum is -10. So -5 and 5 are going to be our factors. So you have u minus 5 equals 0, or u minus 5 equals 0. Since they're identical, I'm only going to write one of them. Solving this, we would add 5 to both sides. And we will replace the u with x squared. To undo the square, we'll square root both sides. Don't forget your plus and minus. And then we'll go ahead and check it. So just plugging that in. So the one part that might be kind of tricky is the square root of 5 to the 4th. So that'd be square root of 5 times square root of 5 times square root of 5 times square root of 5. So 2 square roots of 5 make a 5, and the other 2 square roots of 5 make a 5. So yeah, 5 times 5, which is going to be 25. minus 10 times 50. So the 50 came from the square root of 5 squared. The square and the square root undo each other, so you just have 10 times 5, which is 50. And that equals 0. Give yourself a happy face. Now we can do the same thing with the negative. Because we're raised into the fourth power and the second power, the negative doesn't matter, so it works out an identical way. And we have two solutions. And the final one we looked at today was x to the 1/2 minus 3x to the 1/4 plus 2 equals 0. We're going to check the smaller exponent, which is 1/4. We're going to multiply it by 2, and we in fact get 1/2. So that's a good indication that's in quadratic form. We'll let u equal the smaller exponent. U equals x to the 1/4. U squared will be x to the 1/4 squared, which is x to the 1/2. So that looks good. So u squared is x to the 1/2. And we'll go ahead and replace the x to the 1/2 with the u squared, and the x to the 1/4 with u. And we want a product of 2 with a sum of -3, so minus 2 and minus 1. Okay, and solving both of these, u minus 2 equals 0. We add 2 to both sides, u equals 2. The other one, u minus 1 equals 0. We add 1 to both sides, so u is equal to 2, or u is equal to 1. Replacing the u with the x to the 1/4. X to the 1/4 is the same thing as 4th root of x. That's just the notation. What undoes the 4th root is the 4th power, so we'll take the 4th power of both sides. So x is equal to 16, or x is equal to 1. And then we'll go ahead and we'll check. Okay. So we'll plug in 16. Square root of 16 is going to be 4, minus 3. 4th root of 16 is asking us what number to the 4th power is 16. 2 to the 4th power is 16, so the 4th root of 16 is 2. Plus 2, working all that out, we get 0, so that's good. And we'll try 1. 1's a little bit easier. The 4th root and the square root of 1 is both 1. And we get 0 also. So we have two solutions, and they are both good. Okay.